how would you define innovation? Basically, it's just getting shit done.
Welcome back to KIIPSODES. I'm Ice, and we're back with the second episode of our series with Fiume. And building on our previous episode on artificial intelligence, Mirko will be exploring machine learning in this episode and how these concepts can be used to revolutionize the legal landscape.
Welcome back. I'm Mirko Bernardoni, co-founder and chief scientific officer at Fiume. I'm here today in order to introduce you about what is machine learning and what are the differences between machine learning and artificial intelligence, specifically in the legal sector. Machine learning I consider like the most interesting area of artificial intelligence. It was coined as a term in the 1959 by Samuel Arthur, EPM Journal of Research and Development, and it means a field of computer science that give computers the ability to learn without being explicitly programmed. And this is the big distinction. The example that I show you until now, we're speaking about, I know what are the rules, I know what are the paths that we need to follow. There may be more than one path, maybe a spider web, doesn't matter, but I can control each one of them. And this specific, I have no idea what is the path. I only know what are the data that I give to input and the data that I give as output. I let the machine decide what is the optimal path in order to do that specific task. I think that I can spend a lot of time trying to explain what is machine learning as definitions, but it will be always confusing. Then I decided to ask help to my friend Teddy. Teddy is a bear, okay? So, if I show you some picture of Teddy and some picture of a friend of him, that is the grizzly bear, you can understand the difference. You see, black bear and grizzly bear, black bear on the top, grizzly bear on the bottom. Okay, just keep 1 second in mind this difference based on the picture. Now, if I show you this picture, what do you think it is? I think the right answer is a black bear, maybe Teddy. Then it's better that if you run away because it's dangerous. But I never show you a black bear picture that's showing his face, his front. I was taken from the side. How did you manage to understand that one was a black bear? What's happened on your brain that's specific? To be honest, you do these kind of things a lot of time over the day. Your brain is hyper smart and is able to take what we call features. Essentially are patterns in the terrain picture. For example, the nose shape, the color of the bear, that is black, and you associate this information to the black bear. Now, the grizzly bear has a different color and has a different shape of the nose. Then doesn't matter if you see the picture from a side or in front, you will always be able to recognize which bear we're dealing with. Essentially, this means learning without being explicitly told what to look for. This is the difference from the previous example where we have some rules. I didn't define what are the rules. You were able to find the rules by yourself, just given some data in input and some data in output. Machine learning does exactly that. Okay, it allows computers to learn in the same way. Of course, they don't only identify bears, they do a lot better. But this is the main concept. They are trying to identify features on the data, and based on this feature, use this feature in order to understand what they need, for example, to classify, or what they need to do next. Some good example of data, again, in the legal sector, are contract analysis and review. This is a huge area. There are a lot of tools around that are able to do so. It's interesting because this is a full-fledged EI example. Usually this type of tools, they use all the EI technique, not only machine learning. Such as, for example, you use rules technique and machine learning. So that is more like statistical probability. Because in reality, all the discussion that we got with the bear when you go on the computer becomes statistics and probability, because the machine understands only numbers, unfortunately. They don't understand text, they don't understand anything else that are not numbers. Then what does a contract analysis software? It uses a specialization on machine learning called natural language processing that I will show you later on in deep what does it mean. It uses some rules applied, for example, on the semantic of the sentences, on the position of the word, on the position of the part of the speech, the sentence, and so on, in order to define something. Otherwise, you can use a different machine learning algorithm applied to natural language processing and deep learning in order, for example, to categorize your document or automatically identify some groups or cluster of them in order to see if they're outlier. For example, if you're looking, all the financial document from a bank, and you didn't notice that your kids copied inside your grandma recipe inside the same folder, a machine is able to tell you, oh, look, we have this outlier. That means there is someone that is not like the existing one. There is something weird, and it will show you your grandma recipes. In practice, use it in order to do contract analysis and review. What the machine does is able, let's say, simplify the view, is able to read the contracts, identify predetermined concept, that is essentially our concept of patterns or features, and present this information in order to speed up the review. With one contract, you can argue, oh yes, I may do better. But when we're speaking at scale, when we're speaking about 100,000 of contracts, a machine makes really, really a huge difference, because it's able to work really well on all the standard contracts and asking you, can you please quickly review on this summary page if there is some outlier, something that needs human attention, in order to move faster on that. A good example of that was the labor repapering exercise, where this type of software were used massively in order to go fast and repaper all the necessary documents that are stored, for example, in a huge financial institution. Then you're speaking about maybe 1 million of documents. Another good example is clause acceptance. When you create, for example, a new contract or a new document, often you need to know a lot of subtleties between the parties, because if you know better your parties, you're able to write the right clause, and you know which one will be most likely to be accepted. I use it most likely as a term intentionally because it comes from statistics, and because it comes from the statistics, we can do it with a machine too. And this is another good example of machine learning deep learning applied, because again, we are able to read these documents, extract the specific patterns, especially on the acceptance of the contract between clients, for example, and then automatically tell you, look, you should add this clause because you're trying to write a previous contract like the one that has been written 10 years ago. And these two parties agree most likely on this set of clause, might be knowing their own history on what's happened in that past time. As a result, you get a huge cost reduction because you don't need a really senior lawyer that goes through all this information that was in the company 10 years ago, but a more junior figure is able to do so because you have a computer that remembers for you. And you have productivity increase because it gets a lot faster. Essentially, you don't have to ask around and spend time on endless conversation, try to remember and find where was that things. And definitely will help you to build a better set of client relationship because you're able to create your deals a lot quickly and efficiently than before. So anticipated natural language processing type of concept, but in practice, how we can make this possible? You might be going to become a lawyer, or you're working in a legal firm as a lawyer or similar. Then you don't have that type of capability, and no one will never expect that you will be able to do so. Because there is a field that is called data science. Data science, it's a kind of strange field because it's an interdisciplinary science. This means that it's not someone specialized in only one sector, but has a good knowledge on three big areas. These three big areas are the following: computer science or IT. This means having the ability, for example, to creating programs, but not as good as a developer, because a developer studies computer science and is highly specialized in that. Data scientist is not. Has a really good knowledge about math and statistics, because as you can infer now, it's everything about probability, statistics, and mathematics. But again, it's not a mathematician or statistician, then it's not as good as them, but has a really good grasp of it. And because we are legal, it has a good legal knowledge, but it's not a lawyer, definitely. It's just an intersection between these three big fields. I need to mention also that if you look at the three fields, you look, for example, the intersection between computer science and math statistics, you can extrapolate that there is where it sits in machine learning. If you look legal knowledge and computer science in the legal environment, this is where you have your standard software development and standard software applications. If you look legal knowledge and math statistics, you might have traditional research. With traditional research, I mean academic research, going in the legal sector, by legal PhD, collaborating maybe with the mathematical departments and linguistic in order to do some specific task, and they will publish academic paper. Then what is specifically, it's something definitely new. It's a new form of art, honestly, that is able to get out insight and put the data to work in order to give you the application that I showed you before, or that type of use cases. But again, data science is interdisciplinary science, then it's a big area. In order to make it work on the legal sector, we need a subsection of it. We need a more specialization on that specific. This specialization is called natural language processing. It's not only something for legal, it's used in many different fields, everything related to language. This is another cross-disciplinary approach in the specific, and you can see that is a mixture between mainly machine learning. Remember, machine learning, it's computer science plus math and statistics, and linguistics. What does natural language processing? It uses machine in order to understand better and better how, as a human, we express ourselves by voice, by written text, and so on. His goal is to be able to make computers to understand, that's natural language understanding, there's a subsection of that, and duplicate human language. Interesting application of natural language processing are sentiment analysis, or the ability to identify what are the hidden sentiments, for example, on a specific text. A common use is with Twitter tweets. For example, some famous people like Trump, they have different sentiment based on what he was talking about. And you want to know that in order to make informed decision. It's used, for example, stock market and other area. You can use it also from the communication from your clients. But how you can do on something written, you can do also with a voice, for example, recordings. Personal assistants. There are many of them, like Alexa, like Google, like Siri. This is a good example of natural language processing that everyone is used to. Translations, I think that almost everyone uses at least once Google Translate to see what that specific words mean in a different language. Chatbots, again, chatbots you see today is almost all the website, they must have a kind of chatbots. Are the type of interactive question and answering system that are able to give you information when you express yourself in a normal way, like if you are communicating with a human. Entity identification is the ability to identify specific information. For example, on a contract, I can tell you, okay, this is other parties involved. This is the location where the contract has been stipulated. This is the legislation, but this need to be followed, and so on. Grammatical accuracy, again, it's a really good example because everyone uses it at least once in their life. The spell check correction that you have on Word that doesn't correct only the words but give you also the right grammars, or maybe use Grammarly. That is another application that does exactly the same. Interactive voice response, that one I found it really annoying, but it's an interesting application too. It's, when you try to call a call center and you have the voice on the other side and you have to speak, that one. I think that for today, this is all. I will be happy to collect any question you might have and maybe suggestion for possible next episodes.
Thank you, Mirko, for your presentation. I definitely learned a lot from the last two sessions and hope everyone watching can take a few things away as well. And if you want more bite-sized content like this, be sure to like and subscribe to our YouTube channel and follow our KIIPS social media for updates on everything we're doing. All our links are in the description box below. And as always, we would love to hear from you. So do let us know in the comments how you found this episode and what other topics do you like us to explore. Stay tuned to the final episode of Fiume, where we'll be diving into natural language processing.
Thank you.